Alright, so in this video we'll be talking about returning back to your working point, or you're returning back to your toolpath within myCNC, and how that's implemented. We'll be covering two of the main ways this can be done, and we'll be evaluating some of the common scenarios that you may run into, which require you to have some sort of return back to your toolpath, or axis checking, movement back to your working point, etc., etc. So first, let's talk about the two main ways that a tool returns to its toolpath. And to study this, we'll go over a hypothetical example in which we have some sort of a program. We'll be running through that program for a little while, and let's say somewhere at a let's say midpoint within this program we stop it, and we have to move the tool for evaluation or perhaps for cleaning, etc. And the reason we move the tool is typically because we can't actually reach it from the point on the machine that it is located at the stopping point, and we'd simply like to move it closer to the machine's edge. So this is a pretty common scenario on many machines, be it a milling machine or a plasma cutting machine with a plasma cutting torch. And there are solutions for this which allow you to then return back to the working point and to continue working despite this momentary interruption. So first, let's evaluate milling machine setups in this X1366M profile. First of all, we have this program, and then we have the settings within your configuration tab for start and stop, namely the on start section right here. And the lines that interest us right now are these toolpath position checking, go to toolpath position, and lift height, as well as this setting right here. So what does this actually represent? Well, let's start with the toolpath position checking. Sometimes we want to make sure that the working point and the current point are the exact same points. So for example, if we, let's say, run the program and stop it somewhere, let's say here, then we can see that the working point and the current location is different because we have this lift. If we remove our lift height value, set it to 0, and then reload and go back, we can see that when we stop our machine, our working point and our current point are indeed one and the same. And this is important because we did not leave the toolpath, and the machine will essentially start from the exact same point as it stopped, provided we don't move it. In order to confirm this, and make sure that the machine only starts to work again if the point at which you're at is the exact point in the toolpath that you've stopped at, you can enable this toolpath position checking option. Let's say we enable it for axes X, Y, and Z, so it will look at those three axes and it will not bother with the A, B, C, and UV. And after we save it, let's say we go back and try to run this program once again. If we stop this program and then move the tool away, when we press the start button again, the program will not run, and instead you will have this cannot run, need to return to toolpath message right here. So why is this useful? Well, this doesn't allow you to start the program incorrectly at a completely different point. Perhaps if your machine has skipped some distance, or perhaps for any reason you simply don't want the machine to start unless this current point is exactly the same as this working point, this option is very useful. However, for most applications, what you want is not this error right here, but you want for the machine to simply return back to this working point automatically and continue working from there. And this is indeed the way that most milling profiles are configured. So what you can do instead is select this Go to Toolpath Position option right here. You can select the axes for which you're going to be moving, and once we save this and try to run this program again, let's say we stop it somewhere here and then move away. Once we press the start button, the machine will automatically move right back to this working point. Let's repeat this one more time. The working point is now here. Move away. Press start. It moves right back to the working point and continues from that line of the program. However, you may have noticed that this is sometimes problematic, because what happens is the machine moves directly from its current point over to its working point right here. And what this can result in is your working tool, for example your spindle in our scenario, hitting your part or hitting the table and essentially breaking either the tool or the working part. For that reason, we have this option right here for the Go to Toolpath Position, which consists of either direct move, move on top height, or move on lift height. The move on top height and move on lift height are very similar in that they will first move the tool, the spindle, up to a safe position. That safe position may be the top position, or maybe some position that you will enter, and then it will move back to the proper, let's say, X, Y, Z position afterwards. So let's actually try this. Let's say we want to move on top height, and we'll leave the toolpath position X, Y, Z, which we'll move to. Now, if we run this again, what we expect is for the tool, after we stop it and move it away, we expect the tool to first go up and then come back down. So let's press the play button again. We can see that the tool is going all the way up to my top position, and then it's going back to its working point and continues the program from there. What is the top position? Well, the top position is essentially this limit right here, which is, for me it's 200, it's set to be 200, and it's the maximum limit for the z-axis. However, it is often not needed to go all the way up to the upper top limit, primarily because it takes up a lot of time on certain machines, especially if your movement speed is fairly slow. And instead, we just want to lift by a certain predefined lift height. So we can select this move on lift height option and select some sort of a lift height here, let's say 15. As a note, this lift height is the exact same value as you have in here, lift height in millimeters for me, which is equal to 15. Now if we try to do this again, run this program, and stop it. First of all, you can see that I have some sort of a lift height anyway, because it automatically goes up to that lift height since I've entered it in this section in the lift height for spindle. And then let's say if we move to a certain point, it will automatically move to lift height and then return back to the working position and continue from there. So what you may have noticed is that nowhere in this example am I using this back to path button, which is located right in this bottom right corner. And the reason for that is that the back to path button is very often used for plasma cutting applications rather than milling applications. That's not to say that you cannot use the back to path button for milling applications, of course, but what you most likely will have for your plasma cutting profile is you will have some sort of a combination or configuration that looks similar to this. You will have some sort of an automatic movement that will simply move to the exact position for your toolpath, probably through moving to top or lift height rather than direct move, and then it will automatically start the program again without waiting for any additional input from the operator. To contrast this with the plasma cutting applications, we will take a look at the plasma cutting profile and see how it may be different. Alright, so here I have the plasma cutting profile open in front of me now, and what we'll be doing is we will be using this back to path button, which will allow us to return to the working point. So to see how it works, we can go into our macro wizard within our configuration settings and go into the back to path section right here. So we have went over this macro wizard, and specifically back to path macro wizard, in a different video that is posted on this channel, so you can take a look at the back to path video if you're interested. However, to quickly go over the basics, we have lift top, lift incremental, lift absolute, and no lift. So this is very similar to what we had with moving to top versus moving to some sort of an incremental height versus not lifting our work tool, in this case a plasma torch, at all. So I'll keep this at no lift, and you can select a value here for, let's say, incremental lift. Then you can have your two separate moves. So let's say you can have a move back to X at first, so a move on X-axis only, and then a move on Y-axis only. And then you can have a move down option with a move down gap. So this is the distance that remains after you have move down speed, etc., etc. Macro header and macro footer for any additional commands that you may need. However, here let's simply have the simplest possible option. Generate this macro, save this macro, and let's try running this program and use the back to path button here. So here the program has started. Now let's say I have stopped it and moved away. We can use this back to path button, which will move and return to the working point. Notice how the program hasn't started again yet, so this allows the operator to adjust the position of the torch a little bit and gives the operator some leeway. It doesn't have to start automatically. Next, let's take a look at what the start-stop menu is doing for applications such as plasma cutting, because it may be a little different from milling operations with a spindle. So these would be the settings that are most commonly used on a plasma cutting machine. So if you take a look here, we don't have this automatic movement for X, Y, and Z, because again, on plasma cutting you will most likely be using this back to path button, which will return you to the working point to give you one additional step and allow for adjustments. However, we still want to run some toolpath position checking for your X and Y axes to make sure that the point at which you're currently starting is the point on your working toolpath. However, notice here that we did not enable this Z-axis for toolpath checking, and this is very often because, let's say, if we are stopping the program midway through and cleaning the torch, or perhaps fixing something, with the torch, we simply want to move the torch up and down a little bit. As a result, after we start the program again, we want to check the XY position. However, the Z axis position will be taken care of by the torch height control, which is built into myCNC. Therefore, we do not want to check for our Z axis, and we leave this little check mark blank. So let's try this and see how that works. For example, let's say I have moved to working point, started again, let the program run for a little while, stop it. Let's say I lift this tool up a little bit, and then since the X and Y position are still the same, I can simply launch this again, and the program will begin running again. So that's the general idea of it. You can have toolpath checking, you can have automatic toolpath positioning, which is very commonly used on milling applications, and you can have this back-to-path macro, which is separate from it, and is very often used on plasma cutting applications. Of course, for your machine you can combine both of these solutions. You can use different axes, you can use modified macros, etc., etc. However, that's the general gist of things here, and this is the settings that we most commonly recommend for these applications. If you need any more information, or if you have any questions, I recommend checking out the video on our channel that I've mentioned on the back-to-path video, as well as the start-stop manual in our documentation within our quick start section. Thank you for watching.